Okay, in this video we want to determine whether f is equal to the vector function of x plus y squared, comma 2x plus y squared is conservative or not, and if it is, we want to find a potential function. So on the right we have the theorem that we use to determine if something is conservative or not. So you can pause the video here and read it. So let's get started. We say our p would be x plus y squared, this term, and we say our q would be this term, 2xy plus y squared. Then we take the partial derivative in terms of y for p, so we would get 2y because we treat x as a constant. And then we do the partial derivative in terms of x for q, so we would get 2y because we're treating y as a constant, so this y would disappear. And since they're the same, we can conclude that it's conservative. See, if py is equal to qs, then f is conservative. And now we want to find a potential function. And so what we do is we take p and we say fx is equal to x plus y squared. And we do fy is equal to q, so 2xy plus y squared. And then we take the integral of it. And by taking the integral in terms of like x, we would get x squared divided by 2 plus x times y squared plus an arbitrary constant of cy. It's the opposite, so it's x, so we have arbitrary constants of y. And now we do the same thing for fy. We take the partial derivative in terms of y, so we have 1 plus 1 is 2 divided by 2, so we would get x times y squared plus y cubed divided by 3 plus cx, arbitrary constant in terms of in terms of x. And now we see all the similarities. So we have x squared divided by 2. Here we don't have x squared divided by 2. So we know that x squared divided by 2 would be cx. And then we have xy squared. Xy squared is here, so that's fine. Then we have cy. Cy is nowhere here, but we can say y cubed divided by 3 would be cy. And so our final answer would be xy squared, x squared divided by 2 plus y cubed. And that's all we need to do.